Hi, I'm Mick. I study law at Balliol College in Oxford, and today I'm here with Patrick Thomson. So, Patrick, would you mind telling us a bit about who you are and what you do in Oxford?
Yeah, I'm a researcher on the water programme at the Smith School of Enterprise and the Environment, which is part of the Geography Department here at the University of Oxford. And I'm working on what we call the Smart Hand Pumps project. It starts from the sort of problem that there are lots of communities across the world, in particular sub-Saharan Africa, who rely on hand pumps to pull shallow groundwater out of the ground for their daily sort of drinking and washing and other needs. And these pumps often break, and for the cost of a $2 washer, these pumps remain broken for weeks or even longer, and this has all sorts of problems in terms of health, livelihoods, and other issues. So our research is trying to improve that situation. So groundwater, essentially, when it rains, water percolates into the ground through the soil and then into the rock, and is held in the rock. It's a bit like a sponge. The rock is like a sponge, and the water is held there in that. And the natural processes by which the water flows through that means that actually that water can be very safe to drink. It can be free of bacteriological contamination, free of chemical contamination. So unlike, say, drinking water from a river, where there may be all sorts of problems that can affect your health, drinking groundwater is often very, very safe. And therefore using these hand pumps to abstract it from, say, between 5 and 50 metres from the ground is a way that communities can get safe water. And these pumps are generally very very well designed but simple mechanical devices that just through someone pumping them you can pull water out of the ground and use it for your daily needs.
So, what does the Smart Hand Pump project mean? Where does the smart come in?
So the smart element came from the idea that if the hand pump itself could tell you as soon as it was broken, we could organise and manage maintenance much more quickly.
Yeah.
So rather than a pump breaking and it taking time for word to get to a mechanic and the mechanic comes and it's delayed, if the pump itself sends a message, the mechanic can come the next day and fix it. So the smart bit was we designed a device that attaches to the pump itself. It monitors the use, so it tells you how much water is being pumped from this pump, and then when the pump is not being used, when it is broken, you can tell that from the data which is sent over SMS, and then we can dispatch a mechanic the same day or the next day to come and fix the pump. What enabled us to do it was two things really, which are related. The first was the mobile phone network has been increasing across the world, and in our case, the area we're working, sub-Saharan Africa, very rapidly. So areas where there is no other infrastructure, there's no roads, there's no mains electricity, there's no sewerage, there's no toilets, there's still mobile phone signal. So people have access to mobile phones, and the network which makes those operate, we use with the smart hand pumps. The second was that the cost of designing and building electronics that could do this has dropped. So in our case, the smart hand pump uses an accelerometer to tell if the handle of the pump is moving, and that is exactly the same accelerometer that you might find inside your mobile phone that tells you which way your screen is, or if you're playing a game, which way the device is. And those are things which a few decades ago would have been incredibly expensive, but now because of mobile phones being ubiquitous, that accelerometer is about that big, it's tiny, and costs a couple of dollars. So suddenly the technology that makes the smart hand pump is now feasible to be made small at reasonable cost, whereas a few decades ago just wouldn't have been possible.
I see. And I hear that now what the current state of the Smart Hand Pumps project is that you're using SMS technology to transmit data from the hand pumps to the central office, but that you might be changing this to an internet-based system. Could you elaborate more about how the internet is helpful to this project of yours?
Yeah, sure. Yeah, so as you said, at the moment we've been using SMS, because SMS is the simplest form. So the idea when we started this was if you could get one bar on your phone, this system would work. But as we expand and scale up, using data services becomes more economical, just generally the better way to go for a number of reasons. And as I said, some of the areas we were working when we started would only have had 2G and being able to use SMS, but more and more they're moving towards using data. So on that front, the mobile internet is very important. Okay. Also, what is important is once the message has got into the central server, and is processed and transformed into a useful piece of information that can be sent to someone to help actually fix the pump. The internet is vital for disseminating that information out to the mechanics, who will then use it for fixing the pumps, to the people who are sort of overseeing the mechanics, to sort of us in our office here doing the research, to say a regulator sitting in Nairobi. All of that uses the internet, and the cost of data coming down to virtually zero is essential to make a project like this, which is currently a research project, viable actually as an operational project.
Okay, and could we ask what you studied at university and why you chose to study what you did?
I studied engineering back in the day, and I chose that because it was a very practical degree that involved problem solving, and particularly problem solving with a focus on people and society, and how you can sort of solve problems that improve things in the world.
That's very cool.
So after finishing my degree, I became an aerospace engineer. So I worked designing equipment for helicopters for a few years. After that, I then went into international development, working for 5 years, different countries around the world. And it was during that time that I started seeing that water issues were really tricky problems that people in lots of different places were dealing with. And that's when I came back to Oxford, did a master's in water science, policy and management, and then my current work continued out of that.
Well, I think that's all we have time for today, so thank you so much for joining us.
Well, thank you. That was
and
great.
sharing with us your experiences and story.
I appreciate it.
Thank you.